Alrighty, so here we are with 12.3. Day 1 is official online learning. No one I know has symptoms of coronavirus, so yay, day 1. Okay, so on that note, we are trying to find the sector area and arc length. So our objectives are to find the area of the sector and find the arc length, which of course we're going to define in a second here. As you are doing these notes, you can of course be following along on your own set, which I have provided in the link in headrest. You can kind of have little mini slides of what I'm doing here. All right. So first thing we are going to do is identify what a sector of a circle is, which if you followed along on the Magic Circle project, this should be no competition for you here. So the sector of a circle is this pie piece here, okay? But officially, it is a region that is bounded by two radii. So those are the sides of the pie piece of a circle and their intersected arc, which is like the crust of the pie piece. So again, radius here, and your intercepted arc. Okay. Again, if you remember back to the circle project, we did actually find the area formula. So the area formula is pi r squared, and hopefully that looks familiar because it's the area of the entire circle. However, we only want this region that has to do with this central angle or arc measure of m. And so we're going to multiply all of that by this m in degrees over 360. So that's like saying I only want this chunk of the whole area. All right, so we're going to try some examples using that. So anytime that we have a formula, the best thing to do is once you find out that the problem's asking for it, to fill it in. So it says find the area of each sector, which means that we are going to want to remember that the area is pi r squared, and then we multiply that by the measure of the central angle divided by 360. They want you to give answers in terms of pi and rounded to the nearest hundredth. So there are going to be two answers here for sector HGJ. So notice that the sector, as the notes are saying here, is named by A on the circumference, C the central angle, and B out back on the circumference. So this sector that we are looking at is HGJ. So H to G, the central angle, to J. They're telling you a few things here. For instance, the radius is 12. We also know that M, or the central angle, is 131. And so we end up being able to fill in the two variables. So the area is going to be pi times 12 squared, because 12 is our radius. And then we're going to multiply that by 131 as a central angle over 360. So again, notice that they want you to give your answer in terms of pi, which means that technically we're just going to find this answer and stick a pi on the end of it. Okay, so answer in terms of pi is just going to be this decimal and then a pi at the end. So we need 12 squared, which is 144, and then we're going to multiply that by 131 over 360. Notice how I've typed it in here. I have 144, and then I decided to multiply that answer, which is 144, by, in parentheses, 131 over 360. So anytime that you want to put in a fraction, remember that you put it in parentheses. Since it's all multiplication and division, it should come up with the same answer, but that's the best way to write it. So we do a 52.4. So 52.4 pi is one of our answers. The other answer is taking this and multiplying it by pi. And notice that it does say pi and not 3.14. So take this answer and multiply it by pi. Pi is up here in yellow. And now we have 164.619, etc. And they want you to round to the nearest hundredth. So that means 2 decimal places. So rounded to nearest hundredth is going to be 164.62 because the 9 tells that 1 to become a 2. So those are our 2 solutions. All right, easy peasy. All right, next one here is talking about a windshield wiper blade. And a windshield wiper blade is apparently 18 inches long. Excellent. To the nearest square inch, thank you. What is the area covered by the blade as it rotates through an angle of 122 degrees? Wow, that's quite a degree. Okay, so officially, without an image, they're saying that the radius is 18 and the central angle measure is 122. So in our formula of pi r squared times the measure in degrees over 360, we're going to be able to fill in pi, 18, which we will then square, and 122 over 360. Again, they want it rounded to the nearest square inch, so we're not doing that whole in terms of pi thing. And so we just need to multiply this. So in your calculator, pi again is up here by the caret. So pi and then 18 squared and then 122 over 360. And you're going to get 344.9. Oh, they said to the nearest square inch. Well, thank you. So 345. We'll write it down for reference sake. The fact that that is rounded to 345 inches squared. All right. So again, what we're talking about here is in an image-wise, if this was like your windshield, which first is more like 180 degrees, the windshield is going wiper is going 122 degrees and then going back, which is odd to think about since it would go off of the edge of the windshield. Anyway, all right. So then we have a segment of a circle, and a segment of a circle is a region bounded, just means surrounded, by an arc and its chord. Oops, that's court. Okay, so that means that the segment of your circle is this guy. And so in order to get it, we're going to take the sector and subtract the triangle. All right, so to use segment, we're going to need the area of the sector, and then we're going to need the area of this isosceles triangle, because these two are the radii, and they're the same length. And so we can find the area of that isosceles triangle by finding its height, or if it's a right triangle, that's really nice because it would just be 2 r's squared, r squared. All right, so here we go with an example. All right, we're going to find the area of segment LNM to the nearest hundredth. And so LMN, oh, because it's LNM, sorry. is the sector, but then of course the segment is this little PC over here. PC, yes, that's what I called it. All right, so in that case, we are going to find the area of the sector. And the area of the sector comes from pi r squared. And your central angle measure over 360. And then we're going to subtract out the area of the isosceles triangle. So the area of the sector has a 9 for its radius and a 120 for its arc measure. And its arc measure and central angle match. So anytime you have an arc measure, not length, but measure, and then a central angle, they should be the same. So, and if they're not, then it didn't work. All right, and math doesn't work. All right, so then we have pi, which we will then multiply by 9 squared, and then we'll multiply that by 120 over 360, which is a third. So we're going to start by getting our sector, and then we'll work through how to get the triangle. So our decimal equivalent here is going to be pi times 9 squared times a third, or 120 over 360. So 84.82, what does it say, nearest hundredth? So 84.82, yep. But then again, we are going to subtract the area of that isosceles triangle. So taking a look at this one here, and maybe going back to some formulas you found in your in your circle project. Again, we are looking at a 9 length isosceles triangle. And so if we want to get this height, remember that height meets at 90 degrees. And so we could actually call this, since this is 120 up here, a 60 and a 60. And then because those are 60 and this is 90, this is 30. So we can either use trig or a special right triangle to find out what the height is and the base is, because those are the pieces that we need in order to find the area of a triangle. All right, so to find, for instance, this length down here, I'll call it x. I'm going to use this hypotenuse of 9 and this angle measure of 60, and then the fact that this is the opposite. So to find my first x value, I'm going to use hypotenuse and opposite, which is sine of 60, and the fact that it equals opposite over hypotenuse. So you thought that trig was gone, but it never is. All right. So in order to solve this, we're going to set it up as a proportion and multiply sine of 60 times 9 and divide by 1, which isn't really going to change it. So double checking I'm in degree mode, which I am. I'm also in function mode. Okay. So sine of 60 times 9, and then technically divided by 1 is the same thing. So we're going to get an x of 7.79. And so that is this opposite side length, which is helpful, except if we want this entire base, because the area of a triangle is a half base times height. We need the entire base, which is 2 of 7.79. So if we multiply by 2, we get an entire base length of 15.59. So my base is 15.59. And now we need to find the height. And so to get the height, which is the adjacent side, if we're using this 60, means that we are going to need to do cosine of 60. And the fact that it equals the adjacent, which we don't know, over the hypotenuse, which we do know. So to solve this, set up a proportion, multiply the diagonal, and divide by the other digits. So we get cosine of 60 times 9, and that's 4.5. So that means that the height is 4.5. So we put that in over here. Getting the entire area of that triangle, we're going to take a half, or 0.5, times 15.59 times 4.5, which is the height, and we're going to get 35.08. And so we're going to take this entire area of the sector and subtract out the triangle in order to get that little moon-shaped piece. And so the moon-shaped piece is 84.82 minus 35.07. Whoops, I put 17. Okay, so 49.75. And we are talking about an area in centimeters, so we can go as far as saying centimeters squared because we're super fancy. All right, so just kind of a side note of finding the area of an isosceles triangle. It seemed that we ended up using trig to find the base and the height. Again, you could have used a special right triangle as well, knowing that in a 30, 60, 90, your opposite side is, what is this? 30, so your height then is this opposite side is the square root of 3 times your 9, or your side length. I'm going back to referencing this here. Let's see. Square root of 3. All right, anyway, you can look it up. Turns out that the special right triangle formulas are given on basically every standardized and even ACT test, so yay for that. So, moving on. Find the area of the segment to the nearest hundredth. So again, same idea of finding a segment, only now they didn't necessarily give us the other piece that was within it. This shaded region that you can see in the second problem. All right. Okay, so to find the area of the segment, again, we are going to take the height, which we don't know, and this base here, which we don't know as well. Is this the one from the previous problem? It is. This is the second sheet so that we could do all of this work that I shoved in over here on this. So, yay for second slide. Moving on. This is the third slide, which is the same thing. Okay, I just did it all in one slide. Shoved it in. Okay, so the next piece that we are going to do is the arc length. And I want to be sure that you know that this is not the arc measure. Okay, because arc measure is the same as the central angle, and it has nothing to do with the arc length. So again, arc measure, kind of have a picture of it on a different slide, but the arc measure references that this measure is, for instance, 82 degrees, and this measure is also 82 degrees. But right now, arc length is actually talking about kind of measuring out how long that is, okay? So measure and angle are these degrees, but length is going to start using distance, like centimeters. So arc length is the distance artificially along an arc. Measured in whatever those linear units are. You'll find that I tend to also put an A for arc length, okay? But you can just do L, that's fine. I just don't usually like to put L because then it looks like length from one-dimensional rectangles, for instance. Okay, so either way, the arc length measure is going to take 2 pi r, which again, hopefully looks to you like the circumference, because that's what it is. And again, in our magic circle project, we did this formula. And then you need to multiply that by the measure of the central angle over 360. All right, so circumference measure and then a piece of that over 360. All right. They also mentioned that M could be the arc measure here, but it could also, again, be the central angle. So whichever one you get. All right. So our last example here is telling us that we need to find the arc length of FG. So following along from F to G. Notice that they're telling you that the measure is 134 and that the radius is 8. They also want you to give your answers in terms of pi, so we'll do that, but then also rounded to the nearest hundredth. So the arc length formula, again, L or AL, is going to be 2 pi r because that's the circumference, and then times the measure over 360. So our r is going to have an 8 in it. And then our measure is 134 over 360. And try not to be confused by this formula, because a lot of times we actually see the radius here and here, and they're both labeled or not, at least one of them. So either way, it doesn't have to actually touch where the endpoint of the arc length is, or the arc that we're trying to find, because the radius is the radius from the center out, no matter where it is. All right. So to find this in terms of pi, that means that we need to find this value along with this value, and then throw a pi at the end. Which sounds messy, but the idea is that I need to get the red pieces and then a pi at the end, and that's in terms of pi. So I get to skip the pi if you're multiplying, so 2 times 8 times 134 divided by 360, and that's 5.95. And notice that it says to round to the nearest hundredth in the next one, so 5.96. And so that is our answer in terms of pi, but then in terms of rounding to the hundredths, we just take our result of 5.96 and multiply by pi. And we get 18.71. All right, so those are our 2 answers. So hopefully, even though I, in the middle, have extra sheets, hopefully we found out what the area of a sector is. That's your pi r squared for just area of a circle in general, but then times m over 360 for that portion. And then arc length, okay, is your 2 pi r, because that's the length of the circumference anyway, but then times m over 360 because it's only part of it. All right, so you will have a 12-3 assignment that you're expected to do. Once you get done with the 12-3 assignment, you'll check your answers with the answer sheet. And then if that still doesn't work, you can go through the 12-3 assignment video to see if you can get your questions answered for that. All right, good luck.